Dr. Nemiah Ladd ist Dozentin für Ökosystemphysiologie an der Universität Freiburg. Ihre Forschungsschwerpunkte liegen auf Interaktion unter und zwischen Pflanzen, Menschen und Klima in der Gegenwart und der jüngeren geologischen Vergangenheit. Insbesondere nutzt sie chemische Marker, die von Pflanzen hergestellt und im Schlamm konserviert werden, sogenannte molekulare Fossilien, um vergangene Veränderungen in Niederschlagsintensitäten und der Landnutzung zu rekonstruieren. Sie war Co-Leiterin des B2-WALD Projekts in der Biosphäre 2 im Jahr 2019, über das sie gleich auch unter dem Titel B2-WALD Dürre in der Biosphäre 2 berichten wird.
I'm very sorry that I'm not able to be with you in person, but I'm glad at least for the opportunity to be able to present remotely and share with you some of the work that I've been doing over the past year and a half studying drought inside Biosphere 2 as part of the Water, Atmosphere, and Life Dynamics campaign. I'm from the United States, and I actually was born in southern Arizona, in Tucson, which is a city that's located in the middle of the Sonoran Desert. And the Sonoran Desert maybe doesn't look so much like what many people imagine when they think of a desert. I think a lot of us think of a dry and sandy place like the Sahara, but this is actually a very vibrant desert with lots of plants that have adapted to live under very low water conditions, and it's actually quite full of life. A few years after I was born, just to the north of Tucson, this very unique place, Biosphere 2, was constructed. And Biosphere 2 was originally made as a place to test having people live inside, completely cut off from the outside world and atmosphere. And the goals with those original experiments of having people live inside of this structure was to see how it would be to have people live completely inside if we needed to do that because the atmosphere and the environment got too degraded on Earth, or if we wanted to send people to live on another planet like Mars, how we would have them live completely inside. And the idea originally was to have people live inside for 2 years at a time, nothing in, nothing out, and they planned to repeat this 50 times, so it would go on for a century, learning each time a bit more and improving how it was for people to live on the inside. And for a lot of reasons that I won't go into, this ultimately was unsuccessful. There were only 2 enclosure missions where people lived inside. And then after that, they decided not to continue with the enclosure experiments. But there was still this amazing, unique facility with a lot of opportunities for ecosystem research that now existed in the desert. And it was originally taken over by Columbia University for several years, and now, since 2007, has belonged to the University of Arizona. Inside Biosphere 2, there's the living space for the people who lived inside, so including their kitchen and little apartments. There's also these wilderness biomes. So this is looking towards the savanna. At the far end past that is a dome with desert inside of it. Below to the left in this figure, or in this photo, there's a little ocean down there and a mangrove swamp. And then directly behind where the photo is taken is the rainforest. These are a few photos showing the inside of the rainforest. This structure in the middle is this little artificial mountain that I'll talk about later. And this is one of these atmospheric towers. It only is broken because it's a panoramic photo. Normally it's straight up. And this rainforest is very unique. It's been growing as an intact ecosystem for about 30 years now. The plants were originally brought there from the Amazon rainforest in Brazil. And there's been quite a bit of evolution in this system. Not all of the plants have made it. Several have died off. There's less biodiversity than it used to be, but some plants have really thrived in this environment. And the rainforest inside Biosphere 2 is actually the warmest rainforest in the world. It's quite warm outside in southern Arizona. And then that's amplified, it's made stronger because of the greenhouse effect inside. So light comes in, it turns into heat when it hits the ground, and then that heat can't go back out through the glass. So it's quite warm inside, and it also has very high carbon dioxide concentrations because the air is mostly cut off from outside. So the average CO2 inside is about 500 parts per million, where inside this rainforest, whereas outside today, it's just over 400 parts per million. And in the before the Industrial Revolution, when we started burning lots of fossil fuels, it used to be 280. So in many ways, this rainforest represents where some of our natural rainforests might be headed in the future, with warmer temperatures and higher carbon dioxide concentrations. And this rainforest is also a really exciting place to work as an ecosystem scientist because of the unique niche it holds, both in terms of its scale and the level of control that you have as a researcher there. So as an ecosystem scientist, you could do an experiment in a growth chamber that would be on a very small scale. So this plot has scale on the x-axis in meters going up exponentially, and degree of control on the y-axis, just as a qualitative expression. And in a growth chamber, it's just a little box where you can say exactly what the temperature is, exactly what the light level is, exactly what the humidity is, grow little plants in pots, and learn a lot about processes, specific processes in those plants with a lot of control, but not so much about how plants might interact with each other or other aspects of their environment. At the other extreme, with very large scales, but not much control, we have observation networks that go on the scale of continents, and those can measure big processes in very natural systems. That's what we ultimately want to understand, but it can be hard to really understand the processes when you're working on that scale, and you can't do experiments and manipulate a whole continent. Biosphere 2, the rainforest and the other ecosystems inside here fill a very unique role in that they're complete whole ecosystems that we also have a lot of control over. And we can do things, for example, like turn off the rain, which is what we did last fall. So this was part of the Water, Atmosphere, and Life Dynamics campaign, or WALD, which I organized in 2019 along with Laura Meredith from the University of Arizona and Christiana Werner from here in Freiburg. And we pulled together a huge team to do this project. And I wasn't even able to show everyone that was involved in this slide, but in the end we had more than 70 researchers, students, and technicians from 15 universities and institutions in 6 different countries that were involved in this project. And they brought together a whole bunch of different expertise from different areas of science to study how drought impacts this rainforest. This is a schematic showing the overall schedule for the experiment that I made in January of 2019. And we ended up following this pretty closely. So I wanted to explain how the experiment was set up. Last summer, we started by setting up the experiment, and then in early September, we measured a lot of things about the system while it was still in the pre-drought with its normal amount of rain. Then a little bit later than the timeline here, in early October, we turned off the rain and started drying the system down. And then once it was quite dry and in a drought, we repeated all of the same measurements as before. And then at the beginning of December, we added some special water with a tracer in it to the bottom of the rainforest. So this is another cool thing working in Biosphere 2. There's a basement below the rainforest, and we could go put water in from the bottom and see where that moved. And then eventually, in the middle of December, we turned the rain back on and let the system recover. And we measured how water and CO2 and organic molecules were moving through the system during that time. In order to do that, we needed a lot of specialized equipment. So this is all of the equipment from our lab in Freiburg that I packed up last spring to send to Arizona. And so this is it getting ready to leave Freiburg, all nicely organized on pallets, ready to go. It was supposed to take about 10 days to get to Biosphere 2. And I left in time to be there when it arrived. And then it took another 3 weeks after that to show up. So almost a month in total. And then when it finally did arrive, one of our pallets looked like this coming off of the truck. And it was clear that it had actually been crushed by a forklift in transit. Fortunately, none of the really expensive equipment was on that pallet. And although some things were broken and lost, we were able to recover from this setback. Another setback during my setup trip was we needed to build a laboratory from scratch inside the mountain in the rainforest in order to put all of our equipment and to be making our measurements, monitoring the system. So this is from last spring, starting construction with the laboratory. And this was also something that was very much behind schedule. So when I left from my setup trip on July 11th last summer, this is what it looked like inside. It was still just an empty room with no electricity. And I thought there was no way we were going to manage to start the experiment on time in the beginning of September. Amazingly, when I got back in late August, our team had been hard at work. The laboratory was, this is from a little bit later, but it was looking close to this, full of instruments and getting close to ready to go for the experiment. So this was a huge effort to bring this together. And there was a huge number of people, as I said, that were involved in pulling this off. So what was coming into the laboratory? We were measuring air from all around the forest. So this is one of those towers that I showed in the slide where I first showed the rainforest. And we had tubes at different heights along the tower, sucking air in from the atmosphere and bringing that to the laboratory. We also had these chambers around many of the leaves that had very clean air going into the chamber where we knew how much carbon dioxide and water was in the air and there were no organic molecules. And then coming out of the chamber, we could see how much carbon dioxide the leaf was using, how much water it was releasing, and what organic chemicals it was putting into the atmosphere. We did the same thing around the stems of the trees. And we also looked at what was happening with the roots. So these are roots that we dug up out of the soil and measured too. And we also wanted to look at processes of how gas was moving across the surface of the soil. So this is a soil chamber, and when it was being measured, this lid would close, and we would be able to see how CO2 and water were changing across the soil boundary, and also if organic molecules, organic chemicals were going into the soil or coming out of it, and use that to learn about the microbes, the little microorganisms that were living in the soil. In order to get all of that different air into the laboratory, we needed lots and lots of tubing. In the end, we had about 4 kilometers of tubing that we strung up all around the rainforest. And it came into this little room on the side of our laboratory that we didn't air condition, so we called this the warm room, and it had all of our pumps in there sucking the air in. And it looks a bit like a cluster of all these different tubes running in from everywhere. But it actually was fairly organized where all the positions were coming into. And this is a schematic showing the planning that Laura Meredith and I did to decide where everything was going to go and how it was going to fit in to that warm room in our laboratory before it got fed into these instruments on the other side. In addition to sucking air in from the atmosphere, we also had to collect physical samples from different places in the rainforest. And that included, for a lot of my work, going up and sampling up in the canopy, going up to collect leaves and do experiments on the trees. So the staff in Biosphere 2 installed these platforms for us so that we would have space to work on when we were going up to the canopy. And to get there, we had to climb that frame around the outside of the rainforest. So to do that, we would wear harnesses around our whole body with 2 clips. So you always had at least one of these clips attached to the frame at a time when you were moving. And I wanted to show you what it looked like to climb up there. So this is me climbing with Jason, the rainforest technician. He's a bit faster than I am, but showing how he would move up through the structure. And once we got up to the platform, there wasn't a whole lot of space, but enough to work. And it was also right up by the glass, up high in this hot rainforest. So I think one of the most challenging things about being up there was just how warm it was up there, and managing your fluids, electrolytes, making sure that you were staying healthy while working for hours up in this very hot, extreme environment. Jason has spent a bit more time up there than I have, so he was quite comfortable hanging out when we were waiting for something to happen with the experiment. He would take advantage of the time to do some light reading. We also needed samples from underground, and to do that, we had to dig this giant pit into the ground. So fortunately, there were 3 that were already there from previous experiments, but we last summer dug out this soil pit. So pulled a whole bunch of soil out of the ground. This is it in the basement of the rainforest. We installed siding so the pit wouldn't collapse on itself, and then drilled different sensors into the side so we can monitor what was happening underground. And then we were also able to go into the pits to collect samples throughout the experiment. And we collected thousands and thousands of samples throughout this experiment. So these are some leaf samples getting processed. These are soil samples where people are picking the roots very carefully out of the soil. And this required all of it, a lot of planning and coordination. And for that, we were able to use the old apartments from the people that lived inside. So this is one of their apartments during one of our planning meetings. I'm not going to talk too much about our scientific results, but I did want to show you just a little bit about how this drought went. So this figure is showing the day of the year on the x-axis, and the shading is representing what phase of the experiment we were in. So this white area is before the drought. The light gray is after we turned off the rain, starting in early October. The dark gray is when it was the severe drought phase. This dashed line is when we put water in from below on December 3rd. And then when it goes back to white is when we started raining again. And the important things I wanted to show you here, these top 2 curves are showing you the vapor pressure deficit in the atmosphere. So that's how much water you can think of was missing from the atmosphere. So when it was drier, these vapor pressure deficits in the canopy in purple and in the understory in pink went up. The air got drier. And in the soil, it also got drier. So the orange line is showing you the moisture in the soil at the surface. And that started to go down already. Very soon, the surface soil dried out after we stopped raining. The deep soil stayed the same. It didn't lose any moisture for several weeks. But then by the time we got to the severe drought phase, it also got very dry in the deep soil. So even deep-rooted trees didn't have access to water. And then you can see when we put water in at the bottom, that moisture went up. Same thing when we started the rain, the surface soil moisture went up. And of course, this had an impact on the plants. So you can see a lot of these trees, their leaves started turning brown, and they dropped lots of their leaves. The leaves fell off to the ground of the forest. Interestingly, you'll see a lot of the plants on the ground still stayed quite green themselves. And that's because those plants are used to living without very much light, so they normally grow quite slowly. So even though there wasn't very much water available to them, they were actually, most of them were still doing all right under these drought conditions. And then this is just showing you the ground, how it dried out and cracked after we stopped raining. And stopping the rain had a big impact on the CO2 in the system. So this graph is showing you the same timeline like before, and the same shading as before. And the one curve I want you to focus on is this orange one in the middle. And that's the net ecosystem exchange. So at the beginning of the drought, or before the drought and in the early drought, that net ecosystem exchange of carbon is less than 0, which means that the forest was taking carbon dioxide from the atmosphere and it was removing it from the atmosphere. Once we get into the later part of the drought, the net ecosystem exchange goes above 0, and that means that the forest was releasing CO2 into the atmosphere. And then at the end of the drought, once we turn the rain back on, very quickly it goes back below 0, which means it was taking CO2 up again. And this is important because we rely on forests to buffer some of the CO2 that we are adding to the atmosphere. So about 25% of the carbon dioxide that's burned, produced by burning fossil fuels, is actually taken up by the world's forests. But if in the future our forests are hotter and under these higher CO2 conditions, and also more likely to experience droughts and other extreme weather events, they could actually start adding CO2 to the atmosphere and not protecting us from some of that CO2 that we're putting out. But so finally, at the end, we turned the rain back on. So this is raining on the rainforest again. By this point, we were all quite exhausted. There I am sleeping on the floor of the rainforest. And I know I'm just about out of time, but I want to take just a minute to show a little bit of what it was like to be living out here for several months last year. So we were very lucky that the university provided us with housing in these small houses they have on properties that they call casitas, which means little house in Spanish. We got to see lots of the local wildlife while we were living there. So this animal is a javelina. It looks a lot like a wild boar, but is actually not related to pigs or boars. But you definitely wanted to give them a wide berth if you were walking around at sunset. Sometimes I was the only researcher from abroad that was staying in the casitas, but at other times we had over 20 people staying out there, and we needed a lot of food to keep all those scientists going. This is what it looked like inside the casita. So often we would be preparing stuff like sampling tubes for the next day's work, or finishing up finding the roots from the soil, maybe while watching The Lord of the Rings or some other movie in the evening. But we also had some time just to have fun and get to know each other, all of these great team members from around the world. Also to experience the local culture. This is Day of the Dead, which is All Saints Day here, and an important Mexican holiday that's celebrated in Tucson. And finally, we were able to get out occasionally to go hiking and enjoy the beautiful Sonoran Desert and what it has to offer. So with that, I would like to thank you for your attention, and I would be very happy to take any questions.